Hi, this is Chong Kim. Welcome to tic-tac-toe in Java. Okay, I have Eclipse set up here, and what I'll do is let's create a Java project, and I'll call it TTT. All right, and I also need to create a class, and I'll call it position. Okay. Next, I'll need to create a test case. All right, so now I have a test case. If I run this now, it should give me a failure. There it is. All right, so let's create a real test. Okay. So test, and we're going to test new. So position. Okay. So we call the constructor, and we're going to do some tests. We're going to assert equal that the initial position is going to be all blank. All right. So I'm going to just say position to string, which is the string representation of the board. And I'm going to expect that it's x's turn. So position.turn is x. Okay, right now turn doesn't exist, so it's giving me a compile warning, an error actually. So I do a command 1 and see that the hint says create field, so I'll do that, and it's going to be a character. All right, so if I run this, okay, failure, so I'll make this pass now. So, okay, so I have a position, and the board is going to be to character array. Okay, and actually the board doesn't exist yet, so I need to create it. So public character array board. Okay, and the turn is going to start off with x. All right, so now I run it, and it still fails. So let's see why it fails. Oh, that's because I need to create toString. Okay. All right. So toString, I can get rid of this. Okay. What I'll do is I'll take the board and actually new string board. Okay. So I take the array and I create a new string out of it. All right. So let's run this. Okay, it passes. Next, let's do the next one. Okay, is test move. So if I start off with a position, and I'll make a move 1. So I move to the 1 position. Actually, this is saying that it doesn't exist, so I'll just create it right now. Right now it's just returning null, but all right. So assert equal that I'm going to expect x to be in the 1 position. This is 0 base, so this we leave empty. So x and the rest. That's 3, 1, 2, 3, 1, 2, 3. Okay. And that's what it should look like. And the turn should be O. Okay, so why is it still create method move int? Okay, we already, oh, it's not saved, that's why. Okay, save it. Now the error message goes away. So if I try to run this now, it should fail. Okay, and now I need to make it pass. Null pointer exception. So that's because we're returning a null. All right, so when we make a move, we're going to create a new position. But I don't want it. I don't want this to be destructive, so I'm going to create a new board. So character array new board. I'm going to clone it. Okay, And with the new board, I'm going to update the index position. I'll call this IDX, and based on a turn. And I'm going to create a new position with the new board. And if the turn is X, then I want it to be O. Otherwise, it's an X. Okay. And we need to create an position with a new constructor. So I'll just call it board and turn. Okay. I'll just have it just assigned. All right. So let's see. Okay, so let's run this, and this passes. Good, great. So now we have the constructor, we have the move. Let's work on possible moves. So test possible moves. Okay, so we start off with a position, and we create a new position. We make a move 1. We make a move, let's say 3, and move 4. So with all these moves, when we say possible moves, it should give us new integer okay, and it would be 0, 2, 5, 6, 7, 8. And the actual is going to be position.possibleMoves. Okay, and this doesn't exist, so let's go create it. And it's going to return integer array. Actually, I wonder if this will work. We'll try this, and if it doesn't, we'll revert it back. Okay, we save it. Okay, and save. Okay, so let's start off with a list, an empty list. So, okay, a list of, actually, we have to say integer. Okay, new linked list. This is going to be a list of integers. Okay. All right, so we're going to go over an array, and the array is the board. And so if the board is a space, then we want to add the list. So add to the list that integer. Okay, so by the time we're done with the for loop, we should have a list now. So, but it's in the wrong form. We need to have an integer array. So integer array, and I'll call this array. And I need to allocate the size. So new int array of let's see, list.size. Okay. So this allocates a space for it, and then we can use list.toArray and use this form and put the array here. So it'll store into that array. Okay, and this is complaining because it's not compatible. So we do need to make this integer. Okay, so let's go back here and make that integer. Okay, and integer. Okay, and we need to return it. This is going to it stores into the array, and so we just return the array. Okay, so everything compiles. Let's see if it passes. It passes. Great. All right. So there's still a warning here. What's the warning? It says Oh, assert equal. That's because it's supposed to be assert array equals. Okay, and let's see if it still passes, and it does. Okay. All right, so we have possible moves, and the next thing we need to do is check for a win. All right, so test win. So we want to say, actually, we want to say assert true that position. Actually, let's create a new position, and it's going to look like this: XXX 1 2 3 1 2 3. Okay, so with this and the turn is X. Actually, it doesn't matter whose turn it is. I'll just say win for X. All right, so let's handle all the errors here. Okay, so we need to have, I'm going to save this, a new constructor that takes in a string. So let's see, public position string. Let's see, does it take a turn? No, it doesn't. All right. So this board is equal to character array, and this turn is equal to X, the default. Okay. And now it's complaining about win, so let's create the win method. Okay. So for the win method, this will be turn. Okay. Okay, so let's just say it's false for now, so it should fail. Okay, and we can make this and turn true, and this should pass. Okay, so we should have a negative test. So assert false that if I have a new position, then win for X should be false, and this should fail. Okay, so I have the positive and the negative form of it, and okay, so let's make this real. So actually, let's write the test first. So all right, so new position, and this form, okay, it also works for O's as well. So if I say win for O, that should be true. And assert true new position of, now this I'm going to make columns, so X, X, X. Okay, so the first column, that's a win, so win X. Okay, and okay, so we have across, we have going across, and down. This is down, and this one, let's make it go diagonal. So this would be a diagonal, and see what, okay, actually, yes, so this is not quite right. All right, so let me see, 1 2, okay, 1 2. Right, so it starts from the upper right, the center, and the lower left. Okay, and this diagonal is going to start from here, and okay, and this one should be at the end. Okay, there's too many spaces here. Okay, all right, so 1 2 3. Okay, so this is at the right, 1 2 3, and this is in the middle, 1 2 3. This is on the left. So 1 2 3 1 2 3 1 2 3. All right, so this is the other diagonal. So this should give us a failure now. So let's make that happen now. So by default, I'll have this return false, and if Okay, we'll go through it. For I goes from 0 through 3. Okay, so actually it's probably not a good idea to have this as a magic number here. So I'll just call it dim as a dimension, and I'll just set up the dimension here as so public int dim as 3. Public. All right. All right. So this is going to go 3, and if win line of the turn, and I'll give a starting position. Okay, so this one will go across. So the starting position is going to be I times the dimension. That's the starting point. And the increment is going to be 1. So this means that it's going to be 0. The next time around it's going to be 3, and the next time it's going to be 6. So it's going to be for each row. And it's going to go +1, which means it's going to go to the right. So if it's a win, then let's just, we'll return true. Okay. And we don't have win line here, so public boolean win line character turn, and we need the starting point. We'll say start and step. Okay, so we're going to return, by default, we're going to return false. Actually, by default, we're going to return true because we're looking for something that is not the turn. So, okay, so it's going to start from the start, and actually this is going to do it 3 times, so we don't need to say start 0, and the size is 3. Okay, so we can do this by a formula. So we can say that if the board start plus step times I. Okay, all right, so this looks good. If this is equal to, it does not equal turn, then we know that we should return false. That means it did not win on that line. If it passes all 3, that means that we didn't find anything that is not the turn, so we're going to return true. Okay, so this looks good. Let's see if this passes. Okay, so let's see which assertion this failed with. It says 86. Actually, let's go to this one. Okay, so it passed the first 2, which means that it's correct. So we need to go down now. Okay, we can get rid of this. All right, to go down, let me see, where is it? Okay, here it is. So to go down, that would be win line, turn. Okay, the starting point is going to be I, and the step is going to be in steps of dim. Okay, so that should take care of that. And we have an error, so let's see where. Okay, so we're up to the diagonals now. All right, so to handle diagonals, we're not going to go into the for loop because there's only 1 diagonal for each one of those. So we just test it individually here. So if win line turn, okay, the starting point, one of the diagonals is going to be dim -1 in steps of dim -1. Okay. And the other side, the other is going to be starting from 0 and dim +1. Okay, so that would be the major diagonal, and this one would be the minor diagonal. Okay, so if those matches, then return true. Okay, so now let's see. Okay, so it passed. So we have a test that is able to test going across, diagonal, or down. All right, so let's start with the minimax now. Test minimax. Okay, so we have to consider the base case. So the base case is, okay, so we expect it to be equal to 100 if the position of, let's see, if it's, okay, so this is a position and we call minimax on this. And that should give us 100. And we save. Let's fix this up by creating the minimax. And minimax is going to return an integer. All right, so let's just return 100 just to make this pass. Okay, so it passes. All right, so we also have other cases. So let's, okay, so it's going to be negative 100 if it is, I might as well line this up. Okay, it's going to be negative 100 if it's a win for O. And we'll say that, okay, we can just, it doesn't matter whose turn it is because it just detects a win. And if we have, it's going to be 0 if it's all spent. So that means it's a draw. So XOX, OXO, OXO. Okay, so this is a draw. No one wins. So that should give us, okay, so these are the 3 conditions it has to pass. And it should fail. All right, so let's make it pass. So let's see. If it's a win for X, then let it return 100. If it's a win for O, then let's return negative 100. If it's a draw, so nobody wins, that would be if the possible moves size is 0. Is it size? No, length. It's not. Okay. Dot length. Okay. Possible moves length is 0. Then we return 0. Okay. Otherwise, let's just return some bogus number like a 5. Okay. All right, so everything passed. So that means that the base case are handled. And let's set up a position here where, okay, this is going to be 99 if it's white's turn and it could win in 1 move. And this is going to be negative 99 if it's, this time it matters whose turn it is, and it's going to be O's turn, minimax. Because if it's X's turn, then X can block. So we need to make sure that this says it's O. Okay, so this constructor doesn't exist, so let's create that constructor. So let's see, here, public positions takes a string and a turn. So the board is just 2-character array and is equal to the turn. Okay. All right. So now no more compilation errors. All right. So let's run this, and it fails. Okay. Let's go back to minimax. So minimax. Okay. Let's think about what we need for this thing to work. Okay, so what it needs to do is take the list of possible moves. So let's see. You have the possible moves. So this is going to be a list of numbers. Actually, we can just iterate through this. Okay, so let's iterate through this for each. Okay, and the type is going to be integer. The we'll call it IDX, and the iterable is the result of possible moves. Okay, so we have okay, so we're going to make the move, and we're going to call minimax on this, and okay. All right, we need some variables. We instead of calling this variable max or min, I'm going to call it mm for maximum or minimum. Okay, so int mm is equal to, I wonder if I'm able to do this. I don't think so. Okay, so what is this? Null to int. Okay, so I'll just call it integer. Okay, let's see. All right, so so this is going to represent the maximum and or minimum, and so let's see. Let's have some conditions here. So the first condition is that if mm is null, so then I wanted to set the mm. Okay. Okay. Otherwise, actually, we can just say that the integer value is equal to this minimax value. All right. So actually, okay. So we have the value, and we can compare if turn is x and value is less than, actually, if it's x's turn, then we want to maximize. So if the value is greater than mm, or turn is O, so now we want to see if m is, okay, so if the value is less than m, okay, then we want to set it. So mm is equal to idx. Okay, actually, this logic here, I guess I can move this up here and replace this with an or and just put that there. So if the mm is null, then we're going to set the index. Otherwise, or if it's x and the value is greater than mm, okay. So this is just a way to just do maximum or minimum in one shot. Okay, so this should take care of everything. Okay, so I have an extra curly there. All right, so this should be it. So let's see. Okay, and we have the assertion problem, and it's saying 99 but with 0. Okay, so we're getting a 0. Possible move length is equal to 0. Okay, minimax. Possible moves we make the move minimax, and we find the maximum or the minimum one, and we return it. So let's see which one is. Okay, so it's failing on this one. Actually, where is it? Okay, this one. Okay. So it's X's turn. We called minimax. All right, so let's put a little breakpoint here, and I'm doing Command F11 to run the debugger. So let's step into it. Okay, so this is fine. So we step out. Okay, we step back in. Okay, so here's the minimax. So, okay, all right, so this is where we go in. And we see that mm is null. Okay, and the value, let's see what the value is. Value is 100, and we have IDX there. So we have a value of mm of 0. Okay, so that's expected because actually, this is okay. I see where it went wrong. I was supposed to set mm to the value, not the index. All right, so let's quit out of this. Let's go back to the code, and let's put the correct value in there. So this is supposed to be value. Okay, so that makes more sense. Okay, so we have a failure. And let's see what the failure is. 99, but was it 100? And that's because we didn't take care of the penalty. And the penalty is that we're going to subtract 1 for every time. So we're going to subtract 1 because it took an extra move. And because this is recursive, so it'll do it for, because we called minimax here, and that was that would have a -1 as well, and it'll just propagate up, so it does it as many times as the depth. Okay, so let's check this out. All right, so we have a failure. Oh, because we don't know if it's -1 or +1. So we'll say here turn is equal to actually mm plus turn is x. Then we want to be -1, otherwise it is +1. We could just say 1 like that. All right, so there we go. Okay, everything passes. Great. All right, so we have minimax working. We need to find the best move. So test best move. Okay, so we want to, let's have this situation. Actually, let's take both of these situations. And I'm going to replace minimax with best move. Okay, and it doesn't exist, so I'll just create the method. And best move is going to return an integer. Okay, so I'll just put a -1 for now. It's a non-result. Okay, and okay, save this. All right, so we have a failure. Okay, best move. Okay, it is still saying that best move doesn't exist, but here we have best move. So let's see. Okay, so now, okay, just have to resave it. Okay, so all right. So let's make this real. Best move. All right. So actually, it shouldn't be 99. The best move in this case would be the 0 position, because that would make it win. And for this one, also, let's make it a little bit different. I'll put it as the 1 position just to make it a little bit different. So I'll just put a space there. Okay, so let's go here and make it real. All right, so how will we find this? Well, we find it by looking at the possible moves. All right, so we know it's going to be one of these. See, actually, let's put this into a for each. All right, so it's going to be an integer index possible moves. All right, so we have move, and then we call minimax, and see. Okay, so we need 2 integers here now. So integer is null, and integer actually move, and it'll we'll just call it best. Set it to -1. All right, so, and we'll return the best. Okay. All right, so this is going to be the value. Okay, so this is basically the same kind of thing as this this little code. So integer value is equal to the minimax, and then I could say if it's null. Okay, well it's okay. So I might as well just copy this then. Okay, but there's a difference, and the difference is that inside of here we're also setting the best. The best is that index, and when it's done we'll just return the best. Okay, so let's see. Okay, so this passes. So now we have everything ready to actually write the game, and so we can let's create the interface. So I'm going to create a thing called a new class called game. All right, so here we have game, and I'm going to make this, I'll just leave it the way it is, and okay, swing utilities dot, I forgot what it's called. Swing invoke later. Okay, and new runnable, I think. Okay. Right. So the purpose of this this bit of code is that it's gonna create the main loop, where it looks for events and displays the user interface, and it's gonna run this code once everything is set up. So okay, so I need to create the window, and that is is it JFrame? I think it's a frame. So start with a frame, and I wonder if I can give it a title. So I will call it TTT Java TTT. Okay. And frame dot let's see. Let's set let's set the layout. And the okay, so this is going to use the grid, a new grid layout. Okay, and we need a 3x3 grid. Okay, and let's create some buttons. So we're going to create 9 buttons. So 4 to 9. Okay, so we have 9. We're going to create some buttons. So okay, and it's not going to have any text. See, button. I'm going to set the preferred size, new dimension, and the dimension is going to be 100 by 100. Okay, and we're going to add the button to the frame. So frame add button. Okay, so now the button is added to the frame, and we're ready to display it. So right now it's just displaying it. Okay, so here, no, this is outside of the run. It would be right there. Okay, so frame pack, and what pack does is it realizes all these components and makes it all visible. Set visible true. All right, and I think there's actually one more thing that I need to do. Set I forgot what it's called, but there's something about, oh, is it? Let's see. I need to set something. The cursor default close. Okay, this is what I need. Default close operation. And that's going to be exit on close. Okay, so when I close the window, it's going to exit. Okay, this is giving me a warning. What's the warning? Oh, I wonder if I can JFrame. Okay, I wonder if this exists on its own. Okay, all right. So JFrame. Okay. All right, so let's see. Okay, I'm going to run this. Okay, so we have our little grid here. And okay, so what we're going to do is set the background color. Okay, button set background color to be color.black. Okay, so this way the okay, and then we have to set the opacity. Button set opacity true. Okay, so now we have a little grid here, and when we click on it, what I want to happen is that, you know, the position is going to be set, the X or O. Okay, so right now nothing happens. Okay, all right, so let's do that for each of the buttons. So what we need to do is we're going to set a mouse action. Mouse set see. Okay. Oh, it's not set. It's addMouseListener. That's what it was. Okay, so new mouse listener. Okay, so the listener has all these functions here. This is all inside of this run. Okay, so okay. Oh, one other thing that actually, okay, so what we need here is we need access to a position. All right, so we're in a static function here. Okay, so I'm going to create a position. Okay, and okay, so in here I'm going to create. Okay, so you have the position, and I'm going to create a new position here. So see, I mean new game. So game is new game. Okay, right now we're not referring to it. Okay, so for all of these, we're going to just ignore this. So mouse released, and because we're ignoring it, I'm just going to just put these all together. Okay, mouse centered, and we don't care about that. Mouse click is the only one that we care about. All right, so let's see here. All right, so in this loop, I'm gonna refer to the index. So final int idx is I. Okay. The reason why I'm using final here is because this I is being iterated, and I is being incremented, so it's being modified, and you need to have a final variable in order to be accessed in here. So for now, I'm just going to set actually button.set text to be. I'm just going to put an. Actually, I'm going to just put the index there. So okay, just to test, and might as well call this final as well. All right, set text. All right, so I'm going to run this. All right, so if I click on this, I see the 0, 1. All right, great. So, all right, I'm going to quit out. Okay, so that works. I wonder if I can change the font size. Button set font. Font. Let's see, where's the button? Okay, the button's here. So button set font. New font. Okay. Creates a new font. I wonder what happens if I just put a null in here. Style, I have no idea. I'll just say null. But for the size, I'll put 20. Actually, 100. Let's just see how this this is an error here. Okay, string. Okay, so the second one is style. Okay, so it has to be something. So font dot style would be, I guess, plain. All right. So let's see if this works. So now when I click on it, wow, okay, this is great. All right. All right. So we have the fonts. Okay. So we have access to position. So see, mouse clicked and position turn. Okay, this is an error because, okay, cannot make a static reference to a non-static field position. Oh, that's because that's part of game. So I should be able to say game.position. Okay, and this is an error because can I refer to a non-final? So game needs to be final. So I need to go up here and change this to final. Okay. All right, now this is a problem because it's a string and this is a character. So I wonder if I can just do it. No, I can't. Maybe if I'll just do it this way. Just a quick way to convert this into a string. All right, so let's see if this works. Okay, got an error here. And what is the error? Mouse clicked. It's a null pointer exception. Okay, so why? Position. Oh, because I didn't. I need to new position. Okay, I didn't construct it. Okay, so now let's try this again. Okay, so it works. All right. So now when I click on this, I want it to actually make the move. We have the index there, so we're going to say position move idx. Okay. Oh, there's a problem with this. Actually, the problem is that this returns a new position. So I'm going to just say game.move idx and let this pass it through to the game. So now I need to create a method here called move. Actually, I can just command 1 this. Okay, there it is. So, and all this will do is just look at the position. So position is equal to position move idx. Okay. Now let's see what happens. Okay, great. So the reason is why it's an O is because I need to move this down there. All right. But seeing the O is good. Okay, so now if I run it, it's actually making the moves. Okay, now I want the computer to make the move. So after I make this move, then I want to see if the game has ended. Let's see. Actually, how do we know if the game ended? Well, let's actually create that. This should actually belong in the test. So it should be public. Let's write a test for this. So test gameEnd. All right. So assert false. So if I have a new position and I say gameEnd, and this should be false. And assert true if I have a new position that looks like XXX. Okay, and this should say game end. I keep forgetting that it's camel case here. Okay, so let's create this. Okay, so it's a Boolean game end. And how do we determine? Well, okay, let's think about this. All right, how do we know if the game has ended? If it is a win for X, or it's a win for O, or possible moves dot length is 0. So these, okay, all right. So that's how you know it ended. So we can see if we can run this and okay, so everything passed. So great. So now we can say like, okay, after we made the move, we can say if not game position, gameEnd, then we want the computer to move. So game.position, actually game.move, this is getting a little bit convoluted here. Position, bestMove. Okay, so make the move. And when it makes the move, actually we want the index of this, so okay, and best, and we want to set the actually equal to the turn. So game position turn. Okay, so we want to do that actually like there. So we need to create buttons. We have button, and let's create an array of buttons here. So okay, so final buttons. Actually, buttons is going to be JButton, an array of JButtons. Equals new JButton array of 9. Okay, so there's 9 of them, and we need to add them. So there's the button there, and we'll just add it right here. So buttons I is equal to button. Okay, so now we stored it. Actually, not this. Set text. Okay, so let's see if this works. All right, so I'm going to click right here, and hey, it won. Okay, great. So we have a working program. So let's actually, what we should do is if it wins, if somebody wins, so if not gameEnd, okay, actually we'll just do it here. If game position dot gameEnd, okay, then, and this would be just else. We'll just replace this with an else. Okay, so if it wins, then there's a J option pane message. Let's see, I forgot what this is called. There's a way to send a message. Get, set, show. Oh, I think it is show. Show message dialog. Okay, let me see. Show. It's not a confirm. I think it's just message dialog. Okay, so let's try message dialog. Message dialog, and the message is, well, let's just say hello. So let's just run this, and actually, I'm going to quit this because the game could end right here as well. So I need to take this out, put it right here. Okay, and all right. So this way I don't have to do this once. If game position gameEnd, then we want this. Okay, so we have the output. So we're going to run this. Let's just go through. Yeah, okay, it says hello. That's great. So let's make this say who won. So if, all right, so in this case, let's have the last person to move. So see, last turn. Actually, for now, let's just say like if turn is X, so that's you, then it's going to print out actually, actually, let's just see if win of X. Okay, so if X wins, then say you won. Okay. Actually, I'm going to do the J option pane, show message dialog, null and message. And the message, we'll just set it right here. So string message is empty. And we'll just say message is equal to you won. Okay, let's take a look at the others. So else if game position win of O, so that's the computer, then the message is computer won. Okay. Else, well, because the game has ended, we'll just say it's a draw now. So that's the other choice, draw. All right. So, all right, let's play. All right. So we have our little dialog. Our little window. Computer won. That's right. So, well, unfortunately, this is the only way to to start a new game, is to quit and, okay, so I'm going to try to see if I can block, draw. Okay, so there you have it. This has been tic-tac-toe in Java.